So we left off with discrete random variables and continuous random variables. A discrete random variable is a variable what's the variable? That can only change by minimum increments. Okay, cool. And by the way, I have a chat on the side, so if you have any comments or questions, let me know. Okay. Let x be a variable such that x can be any value in the set 1, 2, 3, 4. This is a real number line, and I guess any number. We're going to plot 1, 2, 3, and 4. Values of x. And then x can be 1, or 2, or 3, or 4. And this x is a discrete variable. Okay, I have another one. Okay. We're still going to have x as a random variable.
This is a completely new example from the previous one, right?
Yeah, all new. Even though it's a, let's even maybe change this. We'll make this z, but it's going to still be a variable. C is any value in the set. We're going to start with 0 and then 0.5, 1, 1.5, 2, 2.5, and it keeps going like that. Okay. This is an infinite set, but we're only going to change by minimum increments from each value of x. Or this time z. Z is any value in this set, so we'll have a z on the number line. 0, and try to space out your units evenly and make everything. We'll make a few of these marks, like So these values keep on going, but they are like countable. This is a discrete random variable. I recently taught some stats classes, which is why I keep saying random variable. It's in that book a lot, but we can just say variable. It's a discrete variable. Random variable means the same thing. Okay, so now we do the definition for continuous, random, continuous variables. Put that random back up. Okay, it is a variable that can take on any value in an interval of numbers. Just put in an interval. Okay, so we're going to have a variable, we'll call it x. Standard. Okay, such that x is any value in the set. That's going to go like this in the set. X values, these are going to be real numbers, but we'll just keep it short and say x such that x is less than 7. So in interval notation, or on a graph too, x's, 7. X cannot equal 7, so it's empty here. And everything less than 7 goes this way. So you're going from negative infinity to 7. Don't include 7. This is interval notation. I think we'll have to do another day on this later if it's necessary. But for the example, we're just saying that x is any value on this interval that goes from 7 to negative infinity, which makes x a continuous variable. Okay, another one of these. So starting over, new variable, let's call it w. Okay, w is any value in the set Okay, so your set starts. We're going to have x values such that 2 is less than x, and x is less than or equal to 3. So don't include 2, you do include 3. So with interval notation, the soft bracket means don't include that number. Like this strictly less than sign means don't actually reach 2. And 3 is included in the set. You can have 3 as a value of x. Equal sign right there. It's a hard bracket. Again, we might do this later, but we're just trying to see that w is a continuous variable. And I think it would be nice to do a quick sketch. So your number line is for values of w. Okay. I like to use the circles. So an open circle on 2, closed circle on 3, and all the values in between. So this interval is where you have values of w. Okay, so I think we can move on to something different. We've got a few definitions and then a few more examples. So first definition is kind of easy. Frequency is the number of time. Let's see, frequency is the number of occurrences of a repeating event. This is R. Okay, let's get this over. Okay, and a frequency distribution is a table that lists each category with its frequency. All right, lists each value of the variable. Along with its frequency. Yeah. So this is kind of sometimes called a frequency table, but in stats, it's a frequency distribution for your list of data. So I put some steps down and then we'll try this out. Okay, list values of the variable. Okay, then you're going to have a place to take a tally. Tally the number of occurrences. and then find the frequency. So count tallies to get the frequency. Okay. So the instructions are to construct a frequency distribution for the following data. So just to keep things organized, here's my data. It's going to have, it goes A, B, C. Then A, B. A, B, A. C, A, A. Okay, so the frequency distribution is some table, so I'll start my table. In a sec. So I'm going to have category as my values of your variable. I'm going to have a place to take a tally. And at the end, we'll do frequency. Okay, possible values of the variable are A and B and C. And then you get the frequency, or let's tally and then get the frequency for A. So this is once, 1, 2, 1, 2, 1, 2. So I've got 7 as the number of occurrences for A. Well, the homework about this week's lesson. Yeah, just as a side note from the chat, what we're doing today and what we did last time is going to be on your first homework. All right. B. Tally 1, 2, 3. 3 times. C. That's it. I've got another one though. Okay. Yeah, I'll make another one. Example. Let's start over. Okay, so let's get some data. Let's try this. We'll do just zeros and ones. So 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 1, 0. That's it. Okay, so the frequency distribution is a table with the first side being category, tallies in the middle, frequencies on the end. We've got 0 and 1. The tallies is 1, 2, 3, 4, 5, 6, 7. 7 again. 1, 2, 3, 4.
Professor, where did you get 7? Wouldn't it be 11 of this for the zeros?
Over the zeros, let me see. Maybe I missed a part. Thank you for checking. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10. What did you guys get? Anybody want to share? I think actually 11. I must be missing something, but you were right. 11. Anyway, the tally is just to help keep organized. Last thing for today is very similar to this, just a little extra bit. It's called a relative frequency distribution. Okay, so it's a frequency distribution with an extra column for relative frequencies. Okay. And then we need to say what relative frequency is. Do it like this. Relative frequency. Okay, so you take the frequency and then divide by the total number of occurrences. All right, some examples, and then we're good. Okay, construct a relative frequency distribution. Oops.
Professor?
Yeah.
Are the total number of occurrences, or in other words, the denominator, the bottom one, is that total number of like the numbers in the set, not just specific to like 0, 1, 2, because that would be the frequency, right? Is the total number of occurrences like the total of every?
Yeah, everything in this set.
Thank you.
Oh, thank you. Okay, frequency. Distribution. Relative frequency distribution. Okay, for the data. Okay, I put alpha, beta, beta, alpha is the first row. Then just beta straight through 4 times. And beta, 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 alpha, beta. Oops. I think there's a row that I missed too. I put an extra 3 of those guys on the end. Okay. So you have your category. Then we will tally. Get a frequency. And find relative frequency. We just have alpha and beta. So categories. Just to help with the work we need to do over here, I'm going to put total. So that we'll find this total number of frequencies and use it on the side. Okay, so 1, 2, 3. Also check for mistakes. Beta occurs. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's check. Okay. Helps keeps things organized. And then 12 of these makes 15 total. And you don't have to, well, actually, it is the case that every time you add this sign, you're going to have 1 total here, just as a fun fact. But anyway, 3 over 15 is this relative frequency. 12 over 15 is the other relative frequency. And then that's it. And usually this part's just some scratch work, but like I said, this total does equal 1 every time. So you get 3 over 15 plus 12 over 15 is 15 over 15, reduces to 1. Last example. Okay, oh, this is like word problem. Pet owners were sampled. How many cats they own? How many cats do you own? I'm gonna put half. The results are in the following table, and then okay, so this time we don't have to look at any data. It's been organized for us. We're just going to finish the table with all of the relative frequencies. So that's the first part. A, complete. The relative frequency distribution. So give you a second to write that down if you want to, and then I need to make a lot of space for our table, so I'll have to erase the whole board. Oh, someone raised a hand. Cool. I'm getting used to this.
So just because this is like we're again, so we have to find thing down, but say like for our home, um, we are given, well, just within like the problem, would we be given the total if it's like a word problem, or just, or would it just depend on problem to problem? And in terms of having to like if we were given the table to fill out the relative frequency, would it pretty much just be like you'd always have all the denominators, over 20 as the total?
Yeah. Well,
I don't even know.
um, it may change, the total may change problem to problem, but I'm not trying to trick you. Like this one, I know the total is 25, so I would even tell you like, what did you say? 25. I don't know. I mean, I guess I'm trying to say, I'm not trying to make any trick questions, and if it does seem tricky, just ask me and I'll help you.
Okay, I just wanted to clarify.
And that's for homework and tests. I just want you to understand. Okay, so we have to erase everything. And then, let's see. Okay, so you would be given all of this work, and we're gonna leave the one side blank. And then I guess I could grab another color so that we could fill in the part where you would put answers. Okay, so you would have cats. Frequency. And then you find relative frequency. Okay, so it's possible to own 0 cats or 1 cat or 2 cats until it went up to 5. And it turned out that 7 people had 0 cats. And then 5, 5, 3, 3, 2. And so it would be up to you to fill in this side or to find like one of these values on the side. So we get the total by adding up all of the frequencies. Okay, it's 10 plus 7 is 17, 18, 19, 20, 25 total. And then here we'd have 7 over 25. 5 divided by 25. Here's another 5 over 25. 3 out of 25. And it would be fine with me if you left them as fractions, but just for the rest of the problem, I did change these to decimals. So 7/25 is 0.28. This is 0.2. 0.12. 0.08. Okay, let's do one question from here. What percentage of pet owners own 3 cats? So you go for 3 cats. That occurred 0.12 or 12%. I think we want to start wrapping it up. We've got maybe 5 minutes left, so we'll put in the last definitions and do examples for them next time.
Professor, since there are 3, like number 3 and 4 for the people that have cats are both 3 out of 25, would you add both of the 12% together to make 24% or no?
That's a sort of different question, but I will write that down. So we're gonna do that really quick. So that would be the percent of pet owners that have 3 or 4 cats. So it was the 0.12 for 3 and another 0.12. You said it was 24. That was from. Yeah, I did have that on my notes, but let's stay here. We'll save the definitions for later. So let's do another question with this. I put, what percent of pet owners have 3 or more cats? So add the percent for 3 and 4 and 5, and reduce, simplify your answer. So, 0.12 plus 0.12 plus 0.08 equals. I got 0.36. Which will be 36%. And that was for 3 cats, and that's 3 cats. This was the number for 4 cats. And that's 9 cats. Let's one more, last one. A, B, C, D, E. What percent of pet owners have 0 or 5 cats? Okay, let's see. 0 cats was percent of 0.28. The 5 cats had a proportion of 0.08. Total will be. Oh, I'm sorry. This one was 36%. This one's a mistake. We have to figure out this number. I was looking at the wrong problem. Does anyone have this answer? I mean, I do. It's right. It's 32. Sorry, 0.32. 2%. This one's 36. Okay. Yeah, thanks for the comments. Let me make sure I didn't miss anything. .32. Yeah, you found that mistake, and then someone fixed it, and then we fixed it. And would this be example? Okay, I think we're good for now. So thank you, everybody.